Okay, this is the next question. So if you see the question, determine the total number of 24 mm bolts required for the double bolted double cover butt joint. So we know what is double bolted. So double bolted is nothing but if there exist two lines of bolts, then it is known as double bolted. So if you see in this diagram, so see, of course in the introduction or in the beginning of this bolted connection itself, we have made it clear that for double cover butt joint or simply for butt joint, we have to consider only one side, either this side or that side, means right or left. So forget about this side. And see here, how many lines are there? Two lines. So in each line, there exists n number. Okay, there exists a number of bolts. But if there exists two lines in one side, then that is known as double bolted. So that is double bolted. Double cover butt joint. So we know that again, what is meant by double cover butt joint? If there exists two cover plates, top and bottom, for connecting the two main member or main plate, that is known as double cover butt joint, as shown. Now one more thing is mentioned here. The threads of bolts are not falling in shear plane. Clear. So in this question it is clearly mentioned. If it is not mentioned, we have to assume the threads are in the shear plane or threads are intercepting the shear plane. But here it is mentioned, so no need to consider. Now let us see how to calculate it. And one more thing, in the diagram it is given that, so in the direction of load is known as pitch. So this is pitch and this is edge distance. So edge and end distance, edge and pitch are given. So now, and one more thing, thickness of main plate, how much it is? 12 mm. And thickness of cover plate 10 mm. So these are the given things. And one more thing given in the question is dia of the bolt is given. So first let us write the given things. Given. And if you see here, nothing is mentioned about the type of material or grade of steel and grade of connections, bolts. So if nothing is mentioned, we know that consider Fe415, sorry, Fe410, comma, bolts are of grade 4.6. So we know what is meant by 4.6 and what is Fe410. Okay. Next, dia of the bolt, how much it is given in the question? 24 mm. And what is the dia of hole then? 26. Okay, so that is a given. And thickness of main member, how much it is? 12 mm. And thickness of cover plate 10 mm. And edge distance, end distance, how much it is? End distance 40 mm. Pitch 75 mm. So these are the given informations. So now he is asking us to find the number of bolts required. And one more thing given in the question is load, external load or design load. How much the design load? P or FD. P or FD, we can represent with FD also. 200 kilonewton. Sectional load P or PD. So we represent PD also. PD or FD, which is equal to 200 kilonewton. These are the given informations. So first take down the given informations. After that, let us see how to calculate the number of bolts required. Okay, so first take this information. So now first we have to calculate design shear strength of bolt. So first we have to calculate design shear strength of the bolt. Design shear strength of bolt. So we know the formula. Shear area into permissible stress. So permissible stress in shear is FUB by root 3 into 1.25 into area. See here, threaded portions are not intercepting. There no need to consider the net area. And that it is in double shear. So 2 into pi by 4 d square. So if we substitute, so FUB. So if nothing is given, we have to take 4.6 grade. So it means it is having the ultimate tensile strength of 400. So 400 by root 3 into 1.25 into 2 into pi by 4 into 24 whole square. How much it is? So it comes out to be 167.13 kilonewton. So that is the design shear strength. 167.16. 167.16. That is the design shear strength of bolt. So after calculating the design shear strength of bolt, let us calculate design bearing strength of the bolt. So first you take it down. Next, design bearing strength of the bolt. So design bearing strength of the bolt. Again, for this also we know the formula. What is the design bearing strength of the bolt? V dPb. So it is 2.5 kb Fu by 1.25 into D into T. Yes or no? So that is the formula. So simply formula is nothing but permissible stress into area, that's it. So how to calculate kb? We know that kb is a minimum of E by 3dh comma P by 3dh minus 0.25 comma Fu by Fu comma 1. So out of all those, which is minimum, that is taken as a kb. So now let us calculate it. So I am going to rub this diagram. So kb is a minimum of E by 3dh comma P by 3dh minus 0.25 comma Fu by Fu comma P. So first let us calculate this. E by 3dh. So E, it is given on the question, 40 by 3 into 26. So it comes out to be 0.51 something. So it is 0.513. Next, P by 3dh minus 0.25. So it comes out to be 0.71. 0.71. One next we know that Fu by Fu is 0.98 and 1. So which is minimum now? This is minimum. So 0.53. This is considered as a kb value. So that is kb value. And Fub is a 400. And D is the die of the bolt. It is 24 and T. So how to calculate T? So we know that how to calculate T. How to calculate T? T is the minimum of. So sum of cover plate thickness. How much the cover plate? Cover plate thickness is 10. So each cover plate thickness is 10. 10 plus 10, 20. 20 mm. And main plate is 12 mm. So out of these we have to take the minimum. So which is minimum? The minimum is 12 here. This is minimum. So now substitute these terms here in this formula. 2.5 into kb is 0.513 into 400 by 1.25 into D. D how much? 24. T how much? 12. So we are going to get 118.195 kilonewton. So now he is asking us to find the number of bolts required. So we know that external load. External load is how much? 200 kilonewton. And now the design strength, how much the design strength? So out of these two we have to take minimum. So minimum is 118.195. That is the minimum. So if we divide that external load by this strength, we are going to get the number of bolts or not? Yes, obviously we are going to get number of bolts. Number of bolts required are simply number of bolts, N is equal to external load PD by the strength. So how much the strength? The minimum we should consider. The minimum is, this is the minimum. So this is considered as a strength. How much? 118.195. So 200 by 118.195. So which is 1.69. So 1.69 number of bolts are required. So we can approximate it. So approximate how many bolts are required? So exactly 1.69. So approximately 2 bolts are required. So it required 2 bolts. So place 1 bolt in each line. So total number of bolts present in this connection is 4. But number of bolts present in one side is 2. So this is the answer. So number of bolts required to take that given load 200 kilonewton is 2. So take it down. So each in each line. So if you see in the diagram, so there exist 2 lines of bolts. So each bolt in each line.